For over a century, an architectural marvel has been slowly rising in Barcelona, yet it remains unfinished to this day. With its towering spires and intricate designs, the Sagrada Familia is set to become the tallest church in the world at 172 meters. A stunning blend of Gothic and Art Nouveau styles by Antoni Gaudí, it has already become a UNESCO World Heritage Site, attracting over 4 million visitors each year to witness its remarkable progress. With pioneering engineering techniques, this monumental structure has defied time and expectations. Will it finally reach completion by 2026, or will its story continue to unfold for years to come? In the late 19th century, as Barcelona experienced significant growth and modernization, a renewed focus on religious devotion began to take shape. Amidst a climate of increasing secularization, many sought to reassert their Catholic faith as a central pillar of the city's identity. This desire stemmed from a need to preserve and strengthen the spiritual foundations that had long guided the community, ensuring that faith remained a visible and integral part of Barcelona's cultural landscape. This need led to the conception of an extraordinary project, the Sagrada Familia, a church that would become a monumental symbol of engineering and artistry. The project began in 1882 with a vision of creating a basilica unlike any seen before. Initially designed in a more traditional Gothic style, the church's future took an unexpected turn when new architectural ideas emerged, blending innovation with deeply rooted traditions. By 1883, the project was reimagined, taking on a life of its own. Its design evolved into something groundbreaking, fusing Gothic elements with modern forms that reflected the natural world. The construction began with ambitious plans, aiming to incorporate towering spires and intricate facades. Progress, however, was slow, relying solely on donations, but the dream never faded. Over the decades, through wars and setbacks, the vision endured. Fast forward to the present day, and the Sagrada Familia remains under construction. While much of its structure is complete, the work continues with an expected completion date set for 2026. As each phase of the building process unfolds, it brings the basilica closer to becoming the tallest religious structure in the world. But how has this construction journey, spanning over a century, unfolded and endured through so many generations? At the heart of this cathedral lies its complex structural framework, which is unlike any other church in the world. The Sagrada Familia is a living, evolving organism, with every piece of its construction contributing to a larger, harmonious whole. Gaudí, the visionary architect, envisioned the cathedral as a testament to nature's organic beauty, and this is most evident in the way the building's structural elements reflect natural forms. The columns, for instance, are designed to mimic trees, branching out as they rise towards the ceiling, creating a forest of stone. This design not only adds to the visual magnificence of the interior, but also serves a critical engineering function, distributing the weight of the massive stone vaults evenly across the structure. One of the most striking features of La Sagrada Familia is the use of parabolic and catenary arches. These arches, which form the backbone of the structure, were a revolutionary choice in the late 19th century. The use of these arches was a calculated decision to optimize the building's load-bearing capabilities. A catenary arch, formed by the natural curve of a hanging chain, is inherently stable under its own weight, and when inverted, it creates a strong, durable structure that can bear immense loads. This natural principle was incorporated into the cathedral's design to achieve both beauty and functionality. This innovation allowed the building to rise higher and remain structurally sound without the need for external buttresses, which are a common feature in Gothic cathedrals. In addition to the arches, the construction of La Sagrada Familia also relies heavily on the use of geometrically complex shapes. Fascination with the natural world is evident in the incorporation of mathematical principles into the designs to create a sense of organic unity. Many of the surfaces in the Sagrada Familia are ruled surfaces, meaning they're created by sweeping a straight line through space, forming intricate curves that are both visually stunning and structurally sound. This technique can be seen in the hyperbolic paraboloids that form the vaults of the church. These shapes not only contribute to the aesthetic fluidity of the design, but also distribute the structural loads efficiently across the building. The stone used in the construction of La Sagrada Familia is another critical element that has evolved over time. Originally, the stone was sourced from Montjuïc, a hill in Barcelona known for its durable sandstone. However, as the quarrying of Montjuïc stone progressed, it became clear that the stone was becoming too fragile for the needs of the project. This necessitated a search for alternative materials, leading to the use of stone from various sources around the world, including England, France, and other regions of Spain. Each type of stone was carefully selected for its strength and aesthetic compatibility with the project's vision, ensuring that the building could continue to rise without compromising its structural integrity. The modern construction process of the Sagrada Familia has also benefited from advancements in technology, particularly in the field of digital modeling. In recent decades, computer-aided design and computer numerical control have revolutionized the way the building's intricate stonework is created. These technologies allow for the precise cutting and shaping of stone off-site, which is then assembled like a giant jigsaw puzzle on-site. This method not only speeds up the construction process, but also ensures a higher level of accuracy in the execution of the building's complex designs. The use of CNC machines has made it possible to replicate the intricate, flowing curves of the original models with an unprecedented level of precision. Another groundbreaking innovation in the construction is the use of pre-stressed stone panels in the towers. This technique involves reinforcing the stone with steel rods, allowing it to bear greater loads and resist the stresses imposed by external forces such as wind and earthquakes. These panels are fabricated off-site and then transported to the construction site, where they are assembled with the help of cranes. This method not only reduces the weight of the structure, making it easier to build higher towers, but it also accelerates the construction process. By prefabricating the stone panels, the builders can ensure a consistent quality of work while minimizing the time spent on-site. Another element of the church is its soaring towers, which, when completed, will make it the tallest church in the world. The central tower will rise to a height of 172.5 meters, just slightly shorter than Montjuïc Hill. The construction of these towers is made possible by the innovative use of post-tension stone panels. These panels are pre-assembled and reinforced with steel cables, allowing them to withstand the immense weight of the towers above. The panels are then hoisted into place and fitted together with precise connections, ensuring that the structure remains stable and secure. This method has been particularly effective in overcoming the challenges posed by Barcelona's seismic activity, as the pre-stressed panels are better equipped to absorb and dissipate the energy from earthquakes. While the construction of La Sagrada Familia has made tremendous progress in recent years, it has not been without its challenges. One of the most significant obstacles came in the form of a controversial tunnel that was dug beneath the church as part of a high-speed train project. Engineers and architects feared that the vibrations from the trains could destabilize the building's foundations. But after extensive monitoring and reinforcement, the project was completed without incident. Another challenge that has persisted throughout the building's history is the question of how to stay true to Gaudí's original vision while adapting to modern construction techniques. Many of Gaudí's original plans and models were destroyed during the Spanish Civil War, and the architects working on the project have had to rely on photographs, drawings, and surviving models to recreate his designs. This has led to some controversy, with critics arguing that the continued construction is deviating too far from Gaudí's original intentions. However, the team of architects and engineers working on the project has remained committed to preserving the spirit of Gaudí's vision while incorporating modern techniques to bring the building to completion. The Sagrada Familia's construction exemplifies cutting-edge engineering and architectural innovation. Its extended timeline has driven advancements in building techniques, from parabolic arches to post-tension stone panels. Upon completion, it'll stand as a monumental testament to the evolution in modern architectural and engineering practices. If you enjoyed this journey, hit like, drop a comment, subscribe for more, and turn on notifications to stay informed about our latest updates.